Welcome to my channel. Today this is a discussion about the numerical integration. Okay, and now we first form a general quadrature formula and use this formula. We can take the help of Newton forward formula, then we form a Newton Cotes formula. After that, use that formula, we have to find the Trapezoidal rule and also Simpson Untitled rule. Okay, and see if the integral be here a to b y dx, where I is equal to a to b y dx, where y equal to f of x, y equal to f of x takes a value like y0, y1, y2 dot dot yn minus 1 comma yn, okay, comma yn for x0, x1, x2 dot dot xn minus 1 comma xn. Okay, with respect to that, let divides now divides the interval a comma b into n equal parts whose common difference is here age. Okay, so now we want to draw the curve here. Actually, like from here, x0 to x0 plus nh. Here is x1, here is x2 dot 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 dot, and this is your x0 plus n minus 1 into h here. Okay, and this is the curve y equal to f of x. And x1, this is here y0, y1, y2, this is here yn, this is here y suffix n minus 1. Okay, so this is the drawing here. Okay, if we the domain B, and this is your A, this is your B, that is A to B. Okay, and now I is equal to A to B y dx, that is A to B sorry, f of x dx. Actually, this is a x naught. This is here x naught to x naught plus nh. Then after that is f of x and dx. Let x equal to sorry, x naught plus p into h. Okay, actually p and n are same. And actually divide the interval and n part, and that is denoted by as a p. Actually p here is a variable. So after that, after the integral, in place of p we put here n actually. So that's why I represent as a p here. Otherwise nothing. Dx is equal to h into dp. So that is equal to, if we take here with respect to p, so if we take here x naught, so what happens? P equal to 0 here. If we take in place of x naught plus h, then p equal to n here, okay? So that is the logic. And f of x means x naught plus ph, after the derivative h into d suffix p. So that is equal to that is 0 to n. And now the forward formula, Newton forward formula, we apply the Newton forward formula is y0 del y naught p into del y naught actually. Then after p into p minus 1 by 2 del square y naught. Actually p into p minus 1 into p minus 2. This is a factorial 2, this is a factorial 3. Actually del q y naught and dot dot dot. And this is here. We can take h here, and here is d suffix p. Okay. Use Newton's forward. Okay, Newton's forward formula. Okay, so now integrating this is actually this is a 0 to n, y is 0, this is p, and that is p square by 2 del y naught. This is a p square means pq by 3 and p square by 2. Within the bracket here is 1 by 2, and that is del square y naught. After that we get here p minus 1, and this is a p minus 2, and that is equal to p. This is p square. This is 3p plus 2. This is pq. This is 4p. This is 3p. 3p square plus 2p. P square minus 3p plus 2 multiplied by p, pq, 3p square and 2p. So integrating this, that is p to the 4 by 4, 3 pq by 3, 2 p square by 2. Okay, del q y naught. Okay, and that is here. Okay. Okay. And this is here 0 to n. After the integrating is that. Now put the limit here. In place of p, we put here n. So n y naught. N square by 2 del y naught. This is n cube by 3 n square by 2 half del square y naught. This is n to the power 4 by 4. This is n cube. This is n square. Oh, I think this is a factorial 3 here. Okay, so this is by 3. Factorial 3. This is means 6. So del q y naught by 6. Okay. Okay, this is the Newton with the help of Newton formula we get a general quadrature formula, and this formula is known as the Newton's Cotes formula actually. Okay. After the Newton Cotes formula, we use use this formula finding the trapezoidal rules. We have find the trapezoidal rules here. Okay. Actually, and this is here. Actually, this is known as the Newton Cotes formula. Okay, and okay, Newton's Cotes formula. After they use this formula, we have find the trapezoidal rule. Okay, and this is here. We can use like that. This is x naught plus h here, and when I use here as a n equal to 1, actually n equal to 1, then as a p here is n, and then this is we can write here x is equal to x naught plus nh. So now put here n equal to 1. So from x naught to x naught plus h here. So this is here f of x and dx, and that is equal to h, and in place of n we put here y naught plus half, that is y del y naught. Okay, and you know the formula of del y naught. This is the first difference, that is y minus y naught. Okay, this is here h, y naught plus half, y1 minus y naught. We get here h into, if we take a LCM, then by 2. This is twice y naught, and this is y naught. Okay, we get on y naught here only, and this is our y1. Okay. After that, from here x naught plus h here to x naught plus 2h here, and f of x and dx. Same as we can use the formula like that, h by 2. Okay, this is here y1 plus y2. Similarly, we can write here like write here, this is from x naught plus n minus h, and this is our x naught plus nh, and f of x and dx, and that is equal to same as h by 2 y suffix, this is here 1 to 2, like that 1 to 2. Okay, and we can write here y1 n minus 1 plus yn here. Okay, if we add these three, if we add this series. This is the, if we add this series, then we get here. Therefore, from x0 to x0 plus nh, this is f of x and dx. That is there. See carefully, in place of this is here h by 2 y0 plus y1, h by 2 y1 plus y2. Yn minus y1 plus yn, okay, and take as a h by 2. So y0, y1, y2 dot 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 yn minus 1 plus yn. This is the trapezoidal rule here. Okay, this is the trapezoidal rule here. Oh, actually, this is a repeat. Why not? This is these are the 2 times of that. Okay, in the middle. Now we have to find the Newton 1/3 rules. Then we can take up n equal to 2 here. So we use this formula. When n equal to 2, then x0 to x0 plus h and f of x and dx. Okay, see, in that case what happened here? Actually, this is the trapezoidal rule, so 0 to, this is the gap in here is 1. So in that case we have to take in equal to 2. So this is 2h here. Okay, so that is equal to, this is an h. This is an h. See, this is at n into y0. So we can put here 2 into y0. After that, this is where n square by 2. So we can put here 2 square by 2. So that is here 2 del y0. So now after that, this is a half. This is a half. 1/3 minus half and del square y0. Okay. Two y0. 2 into del y0. So in that case, this is 2 and okay. This is here. We can take LCM. This is here 1 by 6. So this is here minus 1. So this is here minus 1 and del square y0. Then h into 2 y0. Actually 2 del y0 means y1 minus y0 here. So this is here 1 by 12. And now here del square y0. Del into del y0. Okay. So del into y1 minus y0. So del y minus del y0. This is where y2 minus y1 and this is where y1 minus y0. So y2 minus 2y1 plus y0 here. So put here as a y2 minus 2y1 plus y0. So see, so this is h, 2 into y0 plus 2y1 minus 2y0. Okay, this is y2 by 12 this is y1 by this is at 12. If we took here 2, okay. We put here 2, so I am replacing here is 1, sorry. So this is 2 cube by 3. This is 2 cube by 3, actually 8 by 3. And this is 4 by 2. Okay. And now if we take here 6. So 8 2s are 16. 16, 3 4 12. This is here 4. So this here 4 1 by 3 plus y by 2 by 3, 2y1 by 3, okay, plus 1 by 3 y2, 2y1 by 3, plus y naught by 3. Okay, if we simplify, then we get here actually 2y naught or 2y naught. This is y naught by 3. This is h by 3. This is h by 3. Y naught 4y1 plus y2. Okay? Okay? So similarly you can get here like x naught plus twice h or x naught plus 4h, and this is as f of x, and that is equal to h by 3. Now this is a y1 plus 4 y2 plus y3. Okay, similarly we can write here from x naught plus n minus 2 to h to x naught plus nh and f of x, and that is equal to h by 3. This is your yn, this is your 4 times of yn minus 1, this is your yn minus 2. Okay, see carefully. Okay, see the calculation. Now we adding this. Now add this. Now adding this, then we get here x and here 0 to xn plus nh. Okay, f of x and dx, and that is equal to h by 3. Actually y naught and this is the multiple of 2 times of even suffix number, that is y2 y4 plus dot yn minus 2. After that, this is 4 times of y1 plus y3 and yn minus 3. Okay, so this is the formula of Newton. Actually last one is here n minus 1. Okay, this is the actually formula of Simpson one-third rules. Okay, see the theory carefully. Actually, last step follow the step here for the Simpson 1/3 rules, which I have formed here. When put here n equal to 2, that is equal to h by 3, and last line I want to say that y naught and yn. Y naught and yn are multiplied by 1, okay, and the even number suffix are multiplied by 2 here, and the odd number suffix is multiplied by 4 here, okay. See that carefully. So this is here actually actually this is here plus yn would be term addition, okay. So see the formation of, first we have to find here general quadrature, and after that with the help of Newton forward rule we have find here as a with the help of Newton forward rule we find here as a Newton's course formula, and use this formula when n equal to 1. Then we have find here our trapezoidal rule, and the first word there is the last line is there. See, this is by h by 2, and this is here actually y naught plus yn, and into 2 time of within the bracket y1 y2 y3 dot 2, okay. And in the last we have find here putting here n equal to 2. In the second board we see that the putting here n equal to 2, and these rules as known as the Simpson 1/3 rule, okay. And the last step, see carefully, here is the formula of, this is here actually this is here yn was missing there, so y naught plus yn, and 2 times is multiple of the even suffix, and 4 times is the multiple of the odd suffix, and this is the rules of Simpson 1/3 rule. And see carefully, okay. This is the Newton integration. Now in my second discussion is some problem with this trapezoidal rule and Simpson 1/3 rule, okay. Actually here is the next for problem I want to introduce with you. Actually 2 problem, and with the help of Newton's with the help of Simpson 1/3 and also trapezoidal rule here. And again see, I have to repeat the formula here, and this is the trapezoidal rule, and this is limit 0 to x naught plus nh. It means this is they are the n sub interval, and f of x and dx, and that is equal to h by 2. And in the case of trapezoidal rule, always the value of y and y naught or yn, and from the first value of the and the last value are multiplied by 1, and the middle or all the values are multiplied by 2 here. And the Simpson 1/3 rules here is h by 3, okay. And the first value and last value is multiplied by 1, and the odd number suffix are multiplied by 4, and even number suffix is multiplied by 2. And see carefully, first we note that the extreme value and first value always multiplied by 1. It may be either odd or evens. Don't see the even suffix or odd suffix. So first value and last value are multiplied by 1. In the middle, if the suffix be are odd, then we multiply by 4, and odd suffixes are multiplied by 2 here. And this is the rules, okay. Now I want to some problem introduced by all of you. See carefully here. Actually for calculation there was some taken to time, and actually calculation is not a factor. See the system how can solve this problem actually. Okay, that's why I want to introduce to my notes with you. So here is a problem that I use the Simpson 1/3 rules with 2 and 4 subinterval to evaluate the integral, and that is here I equal to 1 to 2 dx by x, and compare with the exact value. Okay, see this is the actually function. Integral means there is the function b here, f of x equal to 1 by x. So see here f of x equal to 1 by x, and we have used the 2 subinterval. So see here 2 subintervals means 2 minus 1 by 2. Actually the upper limit minus lower limit by 2 if there is a 2 subinterval. So that is we get here 0.5. So we take a lower limit be here 1, then after second limit be here 1.5, then we add it 0.5, then we get here 2. Okay, like that. Okay, so this is the 3 values. X value is of x, that is 1, 1.5 and 2 for the 2 subinterval. If we put here in the function, that is we get here 1. Okay, and this is 1. If we put here 1.5 in that we get 1 by 1.5. If we put here 2, then we get 1.5. So with the 2 subinterval, h here 0.5. Okay, h here 0.5. So that is 1 to 2 dx by x. That is for your 2 and 4 subinterval. Oh, actually here is the Simpson 1/3. Use the Simpson 1/3 rules. Okay, not trapezoidal rule. Okay, so that's why h by 3. And you know, in case of Simpson 1/3 rule, I says that to all of you, the first value and last value are multiplied by 1. That is 1, and that is 0.5. This is 0.5. And the middle value, if the odd suffix be odd suffix are multiplied by 4 and even suffix be multiplied by 2. So this is not y0 and this is y1. This is odd suffix. So that's why it is multiplied by 4 here. Okay, and after that we calculate it, then we get 0.6944 is this. Okay, this is for is as the power of 2 is means 2 subinterval is that. Okay, and now the second question is the 4 subinterval. So see here. For 1 we get here 1. If we actually this is a 4 subinterval, so that's why 2 minus 1 by 4. 2 minus 1 by 4. So we get here 0.25. So lower limit we here is 1. First limit is 1. So after adding by 0.25, then we get here 1.25. Then we get here 0.25. Then we get here 0.5. After we adding 0.25, then we get here 0.75. If we added again 0.25, then we get 2. So upper limit here is 2. So from that limit, this is the value of x, and function here is 1 by x. Actually this is 1 by x. If we put here 1, then we get 1 by 1 is 1. If we put here 1.25, this is 1 by 1.25 is that. If we put here 1.5, then this is 1 by 1.5 here. If we put here 1.75, then we get 1 by 1.75 here. And also we put here actually 2, then we get here 1 by 2. Okay, so same as the 4 subinterval, h here is 0.025. Okay, so that is 0.25 by 3, and first limit, first value and the last value are multiplied by 1, you know, and the odd suffix are multiplied by 4. Odd suffix means 1, and this is 3. This is with addition this multiplied by 4, and this is even suffix. This is multiplied by 2 here. Okay, so see carefully. After that we calculate this by calculator. We get here 0.69325. Okay, and now question here is that okay, 4 subinterval to evaluate the integral of I equal to this and compare with the exact value. Now see the exact value. if we integrate from 1 to 2 dx by x, this is log x, this is 1 to 2 log 2 minus log 1. The value of log 2 here is 0.693147. okay, this is 3 number equation I note here. Okay, and compare with 3, compare with 3 and 1 means this is for 2 sub interval. Okay, compare means we subtract this is as a notation as a I, so that is why I minus is to the interval of 2 sub interval, that is we differ by 0.001293. this is the error. Okay, and again compare with 2, this is the 4 sub interval with that, then we get there the point error here is there the difference means there the comparison. Okay, minus 0.000103. okay, this is the calculation for Simpson one-third rules. Okay, and now also introduce another problem is that, see in my book question is there, compute the integral that is 0 to 1 and dx by 1 plus x square using Simpson one-third rules with 2 and 4 sub interval, and then you use them to get the successive approximate value of pi also. Okay, and this is their function 1 by 1 plus x square, and we want to take here as a 2 and 4 sub interval for 2 sub interval, and then we take h as a 0.5, 1 minus 0 by 2, this is 0.5, and if we for the 4 sub interval we take as a h like 1 minus 0 by 4 here, that's why h here is 0.25. So in a single table we use the 2 sub interval and 4 sub interval also. So note that if we lower limit b has 0, so and this is here 1 by 1 plus x square, if we put here 0 then we get here 1. Okay, then after h equal to 0.25, then we get here 1 by 1 plus 1 by 0.25, and if we calculate then we get here actually this is 0.25, this is 0.94117. if we put here as this is 0.25, then we add again 0.25, then we get here 0.5. so this is, if we put here 0.25 0.5, then we get here 0.800 here. Again we add here with 0.25, then we get 0.75, and replace in this place, then we get here, if we calculate, then 0.67 actually. If we put here 0.25, then we get here 1. If we put here 1, then we get here 1.5, 0.5 only. Okay, and for the 2 sub interval we use this table, these and these 3 values, and the 4 sub interval we take all the values. Okay, so using the sub interval in Simpson one-third rule, we get here actually 2 sub interval, this is 0.5 by 3 here. So we take these first and last as a multiple of 1, and the odd suffix are multiplied by 4. Okay, this is the odd suffix. This is, if we noted that for the 2 sub interval, this is y0, this is y1, and this is y2. Okay, say for the 2 sub interval table is these 3 value. Okay, see carefully, this is y0, y1, y2 is not there. Okay, for the 2 sub interval table is this first value, this is second value, and this is the third value. Okay, and then this is called the y0, this is called y2, and this is called y1, and this is called y2. And for the Simpson one-third rule, first value and last value are multiplied by 1. This is, and this is here the odd suffix, this is y1, so multiply by 4 here. Okay, and calculate is this. Okay, and the 4th sub interval we take all the values. So this is there y1, y0, y1, y2, y3, and y4 also. And the first value and last value are multiplied by 1. And the odd suffix are multiplied. This is their odd suffix is 2 here. So this is multiplied by 4 here. And again this is the even suffix, and we multiply by 2. The first step for the sub interval, we always follow. The first step is here for the Simpson one-third rule. First value and last value always multiply by 1 here. So you not need to see the odd suffix and odd suffix, even suffix. And after the middle values all are, if we get suffix be odd, then that value are multiplied by 4, and even suffix are multiplied by 2. Okay, except first value and last value. Okay, so that's why we get here for the 4 sub interval, the integration result is that. And now exact value, integration of that value, if we integrate this is the tan inverse x, and that is 0 to 1 here. This is pi by 4. And now for the sub-interval, two sub-interval, we get that pi by 4 is equal to this value actually. So then we get there multiply by 4. This is 3.13332. Okay. If we use the 4 sub-interval, then pi by 4 is equal to, actually this is 0.785539. Multiply by 4, then we get here 3.14156. And they successively approach the value is pi is equal to 3.14286, correct to the 5 decimal. Okay, so this is the answer to all of you. See carefully. Okay, again I repeat the record here. Okay, there is also again I see the reduction of the Simpson 1/3 rule and Trapizodial rule also, which I do show all of you. So again see the in my page here. Okay, and forming at this is the general quadrilateral. Okay, see, use the Simpson 1/3 rule here actually. Okay, bye everybody.